I'm Corey, and today this is my lightning talk on deployment. The idea for this lightning talk came to me a couple days ago when we were figuring out how to deploy our new Python, Django, and Node React form. We ran into some issues with a very educational experience, and I kind of wanted to share some things that I've learned about the process from Fred and from Jason kind of along the way, supplemented, of course, by my own research. So here we go. So what is deployment? Software deployment refers to the process of running an application on a server or device. It could also be when the user downloads a mobile application from an app store and installs it onto their mobile device and then runs it via a service worker. It is the process of making the application work on a target device, whether it be a test server, a production environment, or a user's computer or mobile device. It's a catch-all expression, and like I said, it is hosted on servers somewhere, either on on-site infrastructure or in the cloud, making it generally accessible outside of a local machine. Basically meaning that the code that I write on my computer is a local machine, and then it's hosted up in the cloud and available often via HTTP requests in a web browser. So that's our start here. Server locations. While many development teams still choose to host applications using on-premise IT infrastructure, others use cloud service providers like AWS, Google Cloud, and Microsoft Azure, which offer IaaS, infrastructure as a service, as well as a PaaS, platform as a service. These are products that help developers deploy applications on live environments without the additional financial and administrative burdens and overhead of managing their own storage and virtualized servers. Server farms are huge warehouses filled with high-powered computers. I will say that AWS has two main servers available for public use. One is in Ohio and the other one's in Virginia. Fun fact, the one in Ohio is right down the street from where my mom lives. And we used to drive past it like every day. It's 170,000 square feet. It is huge. It is like several New York City blocks large. It's way out there in the boonies. And there they have computers running our code in virtual environments on virtual machines. And we're sort of setting up the configuration ourselves. We also are sometimes use containers, which we'll talk about later. DevOps and infrastructure. So DevOps is a methodology and a set of best practices for software development, whose primary goals are to shorten delivery times for new software updates while maintaining a high quality. These engineers optimize how our code runs in the wild, rather than being quote unquote engineers like me or Karen or Patrick or Tyler who are working on features and layouts. And they can save businesses lots of money by focusing on streamlining deployment, making sure that codes work. They work on codes using the code they work on centers around adapters or deployment specs, which are used to plug applications into services that run them. And requests on these servers are very expensive. They require a lot of power to run these computers. AWS and these other Google Cloud platforms, also charge money to host things. So they can save a lot of money for businesses, and also in labor in terms of people who need to be hired to build, house, create, maintain, and operate the hosting infrastructure. More engineers can focus on writing code. The deployment spec is generally written by DevOps engineers, contains instructions for software deployment. It tells computers things like what language the code is written in, what directories and files are needed to open. That also can point out other necessarily processes like, hey, make sure you're pointing to these other machines. At the Coop, we use Monolithic Services, Heroku, and AWS Amplify. to deploy Tux and our other applications. These services provide their own default configurations, which are not necessarily ideal if you have billions of users and requests going on. But it's pretty good for things you want to get up running quickly, things you want tested quickly, and you don't really run into very many snags until you get past a significantly large number of users and requests. It's really easy to get things up and running. The proc files is the deployment spec for Heroku, and it's just a list of a couple command line inputs that get the application up and running. Down the road, so larger applications with multiple dependencies and a heavy need for scaling depend on the computation and a heavy need for scaling depending on the computation load and the number of concurrent users are run with more complex services. Applications with multiple services are run by containers, virtual machines that run the code with automated configuration to optimize how much space or power or computation is needed in a given instant, in a given moment. And they are also open to being tied to other containers as necessary. In these situations, optimization is key. Like I said, hosting and deployment can cost a lot of money. So having good DevOps people, having good pipelines where code is tested can save businesses lots of money and lots of headache. And yeah, that's my lightning talk and my bibliography there.